Students, let us see this problem, which belongs to the earlier concept what we have discussed earlier. Here, a particle is projected vertically upwards with velocity 40 meters per second. Find the displacement and distance traveled by the particle in 2 seconds, 4 seconds, 6 seconds. Here, the particle is projected vertically upwards. So that means let us take some point A. From the point A, in this upward direction, if it is moved, initial velocity is 40 meters per second. So here in upward direction it is moving, at the same time the gravitational acceleration also working in downward direction. G is working in downward direction. So this is A is equal to 10 meters per second square. So here in this case the U and the G are working in anti-parallel direction. So we should first of all we should go to find the displacement and the distance. Should go to find the value of T naught with the velocity is 0. Why? Because since they are anti-parallel direction, the velocity U is gradually decreasing, and at some point of height it is V is equal to 0 value, and again it will come back and increasing the speed, increasing the velocity in this direction. So first of all, let us find the T naught value at point B time. B is equal to the modulus of U by A. That means U is equal to here 40 by A means here 10. That is equal to 4 seconds. So when here you take A, the time T is equal to 2 seconds, which is less than the value of T naught is equal to 4 seconds. So here in this case the distance and displacement both are equal, and we should use the formula D is equal to S is equal to UT plus of AT square. So now use it. U value 40, and the T is equal to 2, and minus of A means here 10. T square means 2 whole square. So here 80 minus 20, that is equal to 60 meters. This is the distance and displacement in this case. And also if you go to B is equal to 4 seconds time T 4 seconds, which is equal to the T naught time of 4 seconds. So here also in this case displacement distance both are equal. D is equal to S is equal to UT plus of AT square formula is to be used here, and 40 into this is T is equal to 4 minus of A means here 10 into T square 2 whole square, right? Sorry, 4 whole square. 160 minus 80 is equal to 80 meters. So this is the distance and displacement. So and when it comes to C is equal to 6 seconds, C value T is equal to 6 seconds. This is which is greater than T naught value 4 seconds. So here to find the displacement directly we can use S is equal to UT plus of AT square, that is equal to S is equal to UT plus of AT square. Then substitute the values 40 into 10 seconds 6 plus minus of A means 10, T means 6 seconds whole square. That means 240 minus 12 120, that is equal to 120 displacement 180 20 240 minus 180 60 meters displacement. It is very easy, but when it comes to find the distance, T is equal to D1 plus D2. That means D1 means the up to the velocity U 0, that is D1. Here earlier we have discussed D1 how to use. This is formula D1 U square by 2A plus D2 means of modulus of a into t minus t naught whole square. Here u square means u is 40 into 40 by 2 into by 2 into a value here 10 plus of a is 10 and the total time t is equal to 6 minus t naught here 4 whole square modulus of so 2 2 is this is 80 plus here 2 square 20 80 plus 20 that is equal to 100 meters. So this is the total distance. So first of all, this kind of problems when you go to until this kind of problem, that means when the velocity and acceleration are anti-parallel, first of all you should find the time t naught and then compare the given traveling time with the t naught and decide the distance and displacement how they are to be calculated by using these kind of formulas. Okay, thank you.